Hey peeps, it's Jedd here from Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with a probability question, and with that in mind, let's dive straight in. They've said to us A and B are two events. The probability that event A will occur is 0,4, and the probability that event B will occur is 0,3. The probability that either event A or event B will occur is 0,58. In question 8.2.1, they've asked us, are the events A and B mutually exclusive? Mutually exclusive. Okay, what does that mean? Mutually exclusive basically means that the two events can't happen at the same time. Now we've got a really nifty formula for this, and I'm going to use that straight away. So our nifty formula is going to be the probability of either of the events happening, so the union of them happening, is equal to the probability of A happening plus the probability of B happening minus the probability of the two events happening at the same time. So essentially, if this is not equal to 0, we know that the events are not mutually exclusive and can happen at the same time. It essentially means that if we were to draw a Venn diagram, there would be an intersection between the two events. Now, the probability of the two events happening would be 0,58 as per the question. So 0,58. The probability of A happening is 0,4. The probability of B is going to be 0,3. And that's minus PA intersection B. So now we've only got one unknown, so let's treat this like our x in equations and keep this on the one side and move everything else to the other side. So when we move everything else to the other side, we're going to have 0,58 minus 0,4 minus 0,3, and that's going to leave us with a total of minus 0,12 equals minus the probability of A intersection B. We then divide or multiply through by a -1, and we're going to have 0,12 equals PA intersection B. What I would do then is say, well, that clearly doesn't equal 0, and therefore events A and B are not mutually exclusive. Okay, so we have proven that they are not mutually exclusive because the probability of the intersection is not equal to 0. Right, I'm going to erase this question and I'm going to start with the next one. So I'm going to give myself a little bit of space. Feel free to fast forward through this. All right, moving on to our next question. They've said to us, are events A and B independent? Are events A and B independent? And I have a sneaky suspicion that I'm going to have needed that answer that I just had. So let's recap. The probability of the A intersection B is equal to 0,12. Okay, so they've said to us, are events A and B independent? Now, when it comes to independence, we know that if the probability of A times the probability of B equals the probability of A intersection B, we know that the two events are independent. So what we are going to do is we're going to check if this is true. Right, so the probability of A times the probability of B in this case is going to be 0,4 times 0,3, okay? And the probability we've already said of A intersection B is going to be 0,12. Now, let's see. So the probability of A times the probability of B is 0,4 times 0,3, and that's going to give us 0,12. Now, what do we notice? We notice that, therefore, the probability of A times the probability of B is equal to the probability of A intersection B. And therefore, events A and B are independent. And that gets you the full marks for this question. A very, very special thank you to our sponsor for making this video possible. Remember to check out our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.